Hey everyone. I wanted to do a quick video. Well, hopefully it'll be quick. We'll see how it goes. On this word here, this competence. This is mainly aimed at the inspectors that I want to talk to really with this video. Not designers, not installers, more electrical inspectors, and most importantly, inspectors of existing systems. And I want to just question this. Relying on the not retrospective attitude to the wiring regulations. So in case you're not quite sure what I'm getting on at, I'm getting on about the point that whenever we have a new version of the wiring regulations, we look at all the new changes that are coming in, and one of the first questions we always ask ourselves towards the end is, oh, is it retrospective? And if it's not retrospective, we go, oh, okay. And we take that on board to mean that we don't need to turn around and improve things from older standards. The new regulations don't all of a sudden mean that older installations were unsafe. We move forward with them and we don't go backwards with them. We apply the regulations, the new regulations, to new work from that point. And that kind of makes sense. You don't want to introduce a regulation that says that previous version was crap or was unsafe. And I understand why we do that. I've been to many training seminars and events. I was at one a few months ago before the announcement of the public draft, and there was a gentleman who was giving a debrief on the potential changes to the 18th edition. And one of the first questions asked to him afterwards was, "Is it retrospective?" He went, "Nah, it's not." So they kind of went, "Oh, that's fine, no change," or they weren't really bothered. And there's one regulation in particular that's been bugging me, and that's the escape routes regulation. I don't know how familiar you are with that, so I'll quickly cover it. So this is a regulation that requires any escape route to have a wiring system to be installed in a way that will not be liable to premature collapse. So we have to have methods of fixings that are going to be suitable for a harsh fire scenario. So we've been putting in metal fixings, for example. Furthermore, with the 18th edition, they're actually changing that from 52111 to 52110, which is basically the same regulation, but it's taking it outside of the escape route scope, and it's actually making it overall. So it's no longer an escape route requirement; it's for all systems liable to premature collapse, which is basically just spreading it out to other systems. Now, I've been going around sites and I've seen new installs going in well, and they've been going into this requirement, to this regulation most of the time, but they're going in beside installations that aren't compliant because they're to an older version. And whilst it's not retrospective, so yeah, fine, that is against the point of the regulation. And this is the thing. Competent person needs to understand why a regulation has been introduced, what the background to the regulation is, and sometimes retrospective doesn't help or doesn't work. In this case, this is a case in point, really. So what I want to do is just try briefly to cover the history that introduced this regulation, and then at the end we can kind of interpret why retrospective isn't suitable here. So these regulations were introduced because of fires. We had a case in 2005, Harrow Court, 2 firefighters killed, a member of the public killed, and there were a few issues here. There were issues with the fire service. One very interesting area, which wasn't really talked about publicly, was that the high-rise flats had a key supply for every single flat, and the occupant had no electricity. There was no power, and the smoke alarm system was on that isolated supply. So the council's installed smoke alarm system was installed on a supply where the consumer could let it run out of money, which, according to the coroner, was potentially a risk that the council were putting upon the firefighters by providing a system that the tenant technically could be in control of the supply for. In the case of this flat, the batteries went in there as well, so there's a potential there that the firefighters were who died were to some level the council were accountable for that. So we'll see this in the coroner bit in a minute. But what actually happened at this Harrow Court? Well, what it was, no power, so the occupier had a tea light, no holder, went to bed, fell asleep, had the tea light burning, went through to the plastic TV, set fire to the room, went up in flames, no smoke alarm went off, so smoke filled. The two occupiers, one, which was this lady here, couldn't escape the room. This gentleman did manage to escape the room, and the firefighters kicked the door in, managed to rescue him, but this lady unfortunately perished. Now, there were a few issues with this, and I mean, Hertfordshire's fire service tackled the fire in a way that was investigated. They were in BA, which is suitable and required, but they had no water because the hoses were up, but the water lock was chained up because of vandalism, and they didn't have the loppers, and so these firefighters arrived at the door of the fire with no water ready, but they could hear this gentleman screaming, so they did what they're trained to do, and they kicked it in, and unfortunately they both died. But the issue really, from an electrical perspective, is this gentleman here was found. This is firefighter Jeff Warnham. He was found in the lobby, and as you'll see in a minute, he was found completely entangled in cabling. Now it's believed that firefighter Miller died fairly quickly in the room, and as you can see here, the building research establishment study that replicated the room believed that there was a 180 degree to 800 degree flashover within 60 seconds of providing fresh oxygen to that smouldering fire, which, having done some reading on that, is it's very, very, very likely and plausible, and he and the lady probably died very quickly. But this guy, firefighter Warnham, got out, and he was found in the lobby. Now, with regards to the cabling in the lobby, this here is the flat in question. So they came up the stairs, they kicked this door in. This is the room that the fire was in, and the smoke then aggressively took hold. The firefighter, one perished in the bedroom with the lady, and the other gentleman with cabling all over here. Now this image is actually of this corridor, and you can see the amount of heat that actually was there has, in this corridor alone, dropped all of the cabling down from the ceiling. So if you imagine that scenario, plus the fact that you can't see near enough in front of you, this entangling is a big issue. And so the regulation has been introduced to adopt this, but it wasn't back then. This is 2005, bear in mind. So what happened? Well, this is the health and safety investigation from the FBU at the time. So quickly read this. Distressing as it is, particularly for friends and family, blah blah blah. Right. Firefighter Miller appears to have been killed instantly inside the bedroom, whilst firefighter Warren was found on the floor of the lobby immediately outside the flat, entangled in electrical cabling that had fallen as a result of the plastic cable trunking having melted. Moreover, specific attention should be drawn to evidence that firefighter Warren was found entangled in the electrical cabling, with melted plastic fire alarm cable insulation adhered to the inside palm of his glove. So it was clear that he had tried to actually remove the cabling. So it wasn't just falling on top of him after he had perished. The FBU believes the evidence indicates that unlike firefighter Miller, firefighter Warnham was somehow able to make his way out of the flat, or he was already outside the flat after becoming entangled in the cabling that had fallen in the lobby area outside. You've probably seen it before with these kind of buildings where you have small contract, affordable contract, maybe not high levels of competent work, but it's the old 25/16 sticky back trunking being fired up with a couple of screws in it for the emergency lighting cable, the fire alarm cable, even landlord rewires, even in the actual flats themselves, especially if they're concrete, it'll all be surface mounted plastic. because you'll have the old MI and they won't want to rewire that, so they put it all in plastic stuff. I remember attending some flats like that myself when I was on the tools. It's a big problem, big problem. So that was one of the areas. The other area here is not known whether the smoke alarm activated or not. However, nobody reported hearing the smoke alarm in the flat sounding at the time. Since it may not have activated, and it had done so, the occupants may have made their way out safely. So had the smoke alarm had been operational, the occupiers may have made their own way out. So it was considered that Stevenage Borough Council may have contributed to the deaths of firefighter Miller and firefighter Warnham, in that they failed to undertake a review of the smoke alarm installations in individuals' flats at Harrow Court to assess their appropriateness, as recommended in BS 5839. And that's something that, as an electrical inspector, we can try to help our clients do. If we go, oh, I'm going ahead. If we go into a building, we find that the electrical supply is a key meter. We know that the likelihood of that running below zero to debt is common in many of these. If the mains smoke alarm panel is on the load of that key meter, then there's a risk that the local authority will need to be aware of. Especially, again, in individual dwellings, maybe there's a err on the side of acceptance there. But when you're in a building of multiple occupancy in a high rise, you've got to consider the risk on others as well, and the liability there that the landlord has. Alright, so going back to where we were. Alright, similarly, until such a time the relevant fire safety completion certificate is made available, or it has been confirmed the installation of the new fire detection and alarm system to the common areas of Harrow Court complied with the latest building regulations of the approved standard. It was the view of the FBU's health and safety investigation to conclude that Stevenage Borough Council may have contributed to the firefighters' deaths if they have failed to ensure that the contractor who was employed to carry out the installation had failed to comply with BS 5839. Yeah, this is with regards to BS 5839 stating that we shouldn't be installing plastic trunking and wiring systems that are going to be liable to premature failure and collapse in these intense heating conditions. So that was the first case, 2005. Now I'll cover the Rule 43 soon, but the coroner at the time did, under Rule 43, report that improvements must be made with regards to cabling, falling in a fire situation, and we'll see soon with Shirley Towers how that was picked up again. But between Harrow Court and Shirley Towers, there's this one, the Atherstone on Stour fire. Now, what's not known with the Atherstone on Stour fire is if the electrical cabling was in any way directly related to the deaths of the firefighters. What is known is four firefighters perished. They entered into a building that was already evacuated, which created a huge prosecution, and it's one of the reasons why the fire service, when they turn up to a fire now, if it's empty, they just won't go in, unless there's a national public significance to a building or something. The roof collapsed with this fire, and this roof collapsing trapped them, killed them. It's not quite known, but other firefighters had reported in the investigations the electrical equipment and cabling was falling down from above throughout the site. So it's not known if cables had entangled these firefighters, avoiding them to escape, or if it just slowed them down. But there was definitely, in the action of tackling this fire, many of the other firefighters had reported that the cabling had affected and slowed down their ability to actually get around inside there. And it's actually here on the operational bulletin there. So at this fire, Atherstone on Stour, the Warwickshire Fire Rescue Service issued the operational bulletin. This is in March 2012, which seems like a long time after 2007, but bear in mind that there was a prosecution in between. It stated that hanging cable hazards from surface-mounted conduit and trunking were present. Okay, and then BRE Global, BRE is the Building Research Establishment, they concluded that the plastic conduit and trunking surface mounted on the ceilings may well have fallen at a relatively low temperature of 150 degrees, which isn't a very high temperature in a fire. That's quite low. Moving on though, The other one that is important, and this is the one that really came onto the introduction of the regulations, was Shirley Towers in 2010. I've got a little video which kind of just describes what happened here, so I'm going to play that here. And then we'll come back and we'll talk about the Rule 43 letter. Okay.
Shirley Towers is one of 3 high-rise blocks of split-level flats in Southampton, Hampshire, managed by Southampton City Council. It has 150 1- and 2-bedroom flats and houses between 350 and 400 tenants. At 20:09 on the evening of the 6th of April 2010, a call was received in Hampshire Fire and Rescue Services control room.
Fire and Rescue, what's the address of the incident?
Hi, it's Shirley Towers. Got a fire on the 9th
Sorry,
floor?
Shirley Towers?
Shirley Towers.
Okay, on the 9th floor. What flat number, please?
72.
Okay, flat 72, and what's on fire?
Within 5 minutes, the first fire crews had arrived and were quickly joined by others. Before the evening was over, 2 firefighters, Alan Bannon and James Shears, had lost their lives.
People have been forced to leave their homes in the last 2 hours after a fire broke out in a block of flats in Hampshire. Crews were called to Shirley Towers on Church Street shortly after 8 o'clock this evening.
The fire broke out on the 7th floor. It's not yet been confirmed what caused it, but police say it's not being treated as suspicious at this time. It was out just before 1 o'clock this morning. Hampshire Fire and Rescue has described the deaths of its 2 firefighters as not only a devastating loss to the service, but to the whole fire service community, adding they will be sadly missed.
Tributes have been paid to 2 hero firefighters who died saving the lives of others. James Shears and Alan Bannon were tackling a fire in a tower block in Southampton. The men were today described as valiant by the head of Hampshire's fire service.
The next day, it was announced a full investigation would take place. This is the story of that evening, the investigation and the impact on Hampshire Fire and Rescue Service.
This was an enormously tragic and difficult incident, both for individuals, personally, professionally, and for the organisation as a whole. And one of the things I think one has to do is remember that these incidents have in them the seeds of learning that we need to take away in order to make sure that we can best protect our staff and indeed firefighters from across the UK in the future. So one of the first things that we did after the press conference in the morning was actually to establish a dedicated accident and investigation team, taking some of our very best officers who hadn't been involved in the incident and set them to work initially collecting data about exactly what had happened. As you can imagine, there was an enormous amount of data, there was an enormous amount of activity from the police, from the health and safety executive, from all the agencies. Their job was to, firstly, to create a timeline of what actually happened at the incident, get a very clear picture so that we could understand what went wrong, what people didn't understand at the time, so from that we could draw the lessons of how to prevent these things happening again.
Shirley Towers was constructed in 1967. It has 16 levels, with 150 flats in total. The split-level flats have stairs either up or down from the front door to the living accommodation, which is spread over 3 levels. The fire started in flat 72 on the 9th level. The residents had draped a curtain over the top of an uplighter lamp in the lounge while hoovering earlier that day. They later turned the lamp on and then noticed a burning smell, but thought it was outside. A little later, the resident realised it was the curtain and pulled it out of the lamp and attempted to extinguish it using a bottle of soft drink. The alarm was then raised by a neighbour who called 999. This is an identical flat to number 72. The first firefighting team, Red 1, were sent in to fight the fire. A second team, Red 2, of firefighters Alan Bannon and James Shears, were sent in to hose manage for Red 1. The firefighters, on entering, climbed the stairs to the lounge and kitchen. The fire was in the lounge, but Red 1 did not detect the fire due to the thick smoke. They commenced a right-hand search pattern, using the walls to guide them. They climbed the stairs to the second-floor landing, where the bathroom and toilet were, past the fire door, which was propped open by the occupant, and continued up the stairs to the third floor, where the 2 bedrooms were located. Here, they opened windows in both bedrooms to help ventilate the smoke. Red 1 then met Red 2 on the bedroom landing, and as the temperatures suddenly rose to unbearable levels, they realized they needed to exit the flat urgently. The teams were unable to escape downstairs due to the fire in the lounge. Red 1 managed to escape the flat by climbing the stairs and going through the emergency exit door into the 11th level corridor. But all contact with Red 2 was lost. Tragically, firefighters Bannon and Shears were unable to withdraw to safety.
Right, yeah. Similar situation there. Unfortunately, those 2 firefighters were entangled with cabling that had fallen down. As you can see in the images, the installation was surface mounted, trunking, and after a fire condition they all fell down. So what was this Rule 43 letter about? Well, under provisions of Rule 43 of the Coroner's Rules, a coroner who believes that any action that should be taken to prevent the recurrence of a fatality similar to that in respect of the inquest is being held will announce at the inquest that he is reporting the matter in writing to the person or authority who may have power to take such action, and he may report the matter accordingly. And what happened in this case is the Shirley Towers coroner picked up the previous coroner's report, compared what had happened, and actually just mapped it and then pushed it through with further suggestion on building regulations improvement and wine regulations improvement with that. So we've got a little example of that here. So in both Harrow Court and Shirley Towers cases, the coroner has issued recommendations through a Rule 43 letter. It concerned that social housing providers regarding the support of fire alarm cables, which should conform as a minimum to 5839-1. In the case of Shirley Towers, which was the most recent event, 2010, further recommendations were to include building regulations being amended to ensure all cables, not just fire alarm cables, are supported by fire resistance cable supports, and a recommendation of an amendment to the BS 7671, which we have seen introduced. Great. These are the recommendations actually from the coroner's letter from Shirley Towers, and you can see how he mentions the other case here. So his recommendation that all fire rescue services and social housing providers consider the Rule 43 recommendation made by the coroner for Hertfordshire, Mr. Edward Thomas, following the Harrow Court case. So this is the Shirley Towers coroner from 2010, referring to the prior case from 2005. So he's saying we need to refer to that. And the recommendations being here that the SBC, so this is in this case probably Southampton Borough Council for Shirley Towers, will remove all surface mounted plastic trunking conduit used to protect and support the fire alarm and automatic fire alarm system in common areas of all of their premises, and replace them with a method of cable support which has a minimum conformance to BS 5839-1. The methods of cable support should be such that the circuit integrity will not reduce below that afforded by the cables used, and should withstand a similar temperature and duration to that of the cable while maintaining adequate support. Alright. They also went on to add, it is recommended that the building regulations are amended to ensure that all cables, not just fire alarm cables, are supported by fire resistance alarm supports. This should be achieved by an amendment to the BS 7671. Now obviously we've recently had the tragedy with Grafnell Tower as well, and we've been discussing there about sprinklers, should they now be introduced, and it was mentioned back here in 2010 that there was a push that for all social housing providers to be encouraged to consider retrofitting sprinklers in all existing high-rise buildings that are in excess of 30 metres in height. So it may be that following graphenol as well, that we're going to have that pushed even further, and they will start pushing them in, retrofitting them into existing buildings. Who knows? So what actions can be taken? Well, it was advised to get this improvement into the regulations, but they had to actually go to the building research establishment to investigate the causes of this collapse. So we have BRE, which is the test lab. They've created a test corridor, and what they did is they installed 5 lengths of 1.5 twin and earth cable, and they clipped 1 length with a normal clip there, and then they had other types of cable clipping, and they were basically going to heat this up and see which ones failed and which ones didn't. And you can see these ones are metallic, and this is just your typical soft cable clip. So 5 types were supported. They were all fixed with zinc plate hardened steel screws, 300mm spacings, and anything that was into a concrete lintel had a simple plastic rule plug used. With regards to the fire, they used 2 experiments, 0.7 megawatt and 1.3 megawatt wood crib. The wood crib is the method of testing for a typical fire, like a living room, or where the fire rises up instead of a pool fire. So it's all about the type of fire they simulate here. And so what they'd have is they'd have some thermocouples, and they'd set one fire up to hit one temperature, and then they'd obviously increase it to another temperature. So they'd be doing 2 tests for 2 maximum temperatures. And these values here, 0.7 megawatt, 1.3 megawatt, these are what we would call peak power. So the peak power of the energy of the fire. Alright, so the results we had were this. So we have 4 lentils, timber concrete. The average maximum temperature, the temperature where the cables seem to drop, and the different types of support. Okay, so this was your cable clip, and then you had these metal types of saddles and other clips. And you'll notice that regardless of this, the maximum temperatures were fairly constant. I mean, bear in mind that there'll be 1 crib, and it'd be a case of which is in closest proximity, really. But we had no drop on lintel 4 with concrete for the cables. That's when that's purely because of distance, maybe. But what we did have is the cable clips all failed. We had 4 fail on that lintel, 4 fail on that lintel, and all failed on those 2. So a simple cable clipping is the worst type of fixing method there. So that's experiment 1. Now, experiment 2 will increase it from 0.7 megawatt to 1.3 megawatt, and so you'll see here the temperatures with experiment 2 increase. So we have timber concrete. We have average temperatures when the cables observed to drop. So here they all dropped really. And we have for the supports, all of the clips failed. So clipping is definitely a no-no. This one, lintel 2, which is obviously in fairly close proximity. Interestingly, with this one, 3 of the supports failed for each support type. So the reason really is because they were on concrete. Now the difference obviously between this concrete and this concrete is the temperature limit. This lintel was obviously furthest away from the crib. This one, which is right in the hot spot, has a concrete fixing, and 3 of these failed, but it was the fixing that was a failure and not the actual clip. So the clip didn't break, the clip held it up. It was the fixing in the actual concrete. And so the weakness there isn't the clip, it's the actual plug. Because the difference between the timbers and the concrete is the concrete has a plastic plug. So what this picked up was the rule plugs. The plastic rule plugs are also a problem. Now bear in mind that BRE also picked up that the actual flash fire went between the range of 180 degrees to 800 degrees within 60 seconds of providing all that fresh oxygen to that fire. So these temperatures can easily be reached in a firefighting scenario. It's quite typical. And if we have plastic rule plugs in concrete, they may fail and drop their fixings. So that brought another question. They needed to test these fixings, and that's what they've done. So they carried out a fixings experiment. They had a 3.6 Newton concrete block, 440 by 215 of 100 mil depth. They placed one with two holding it up in an oven, and what they did is they put each fixing in and they hung from them a big heavy bolt to have a constant weight pulling down on each fixing. So if one was to fail, it would be pulled out. The 5 fixings that were challenged we have here illustrated. So we've got fixing 1 was a countersunk 6mm by 45mm concrete screw. So it's just a concrete screw. 2, a multi-purpose twin thread countersunk zinc plated 4mm by 40mm screw with a 5mm lightweight plastic wall plug. There's a plastic plug there. Fixing 3, hammer-in fixing 6mm by 40mm nylon plug with drive screw, so another nylon plug there. Fixing 4, multi-purpose twin thread countersunk zinc plate 4mm by 40mm with again another nylon plug. And 5 is a sleeve anchor. So fixings 1 and 5 are purely metallic. 2, 3 and 4 have plastic or nylon parts. And the previous testing suggests at a certain temperature point those may become soft, weakened or defective. So they've put that to the test. And the results they got, there's the 100 degrees layout. So this is before they started putting them in the oven. So here's the concrete screw number 1 there. There we have the wall plug plastic, 2 with nylon, and then we have the anchor there, all with these bolts hanging from them. Okay, so the findings they got with the oven temperature at 100 degrees, the maximum temperature in the block. This is what we call thermal mass of the actual structure. So if you apply a temperature to a material, it'll actually conduct that energy, and it will build up a temperature over time. Now it's important to understand this because NAPIT, for example, have said that you don't need to worry about plastic fixings because the thermal mass of the fabric of the wall will absorb all of that warm temperature away, and so the plastic fixing is only a little part. That wall will take all of that away from that. This has proved that to be wrong. When there's enough heat there, the actual block will reach a certain temperature and those fixings will become weak. So 100 degrees in the block went to 58 degrees, no effect to any fixing. Up to 200 inside the block rose to 104, again no effect. Now an oven temperature of 300, which is very, very typical to the low end of what we've been looking at, it can go up to 100 in the block, which is funny really considering that's gone up and that's gone down. We had a weakened result for fixing 2, which is your very, very common plastic wall plug. We go up to 400, which goes up to 109 within the block, maximum temperature in the block. We then have again a weakened plug. We then have a weakened nylon plug. In the case of fixing floor, that failed altogether, so that one fell out. So what's been proven with this is in a fire condition when these temperatures can rise to 400 degrees with ease for a period of time, the thermal temperature within the block will soften and fail any fixings. So these metal fixings need to be held up with metal screws, no plastic plugs. Now if you're going into wood and timbers, that's fine, you're not relying on the plastic plugs, but if you're going into concrete, then yeah, you've got a problem. I've flipped this illustration round because they had it upside down, but you can see there's 1, 2, 3, 4 and 5, and you can see 4 fell out and it's just up there. So there's the result at 400 degrees. So the conclusions of BRE: quite simple and readily available supports and fixing cables of withstanding temperatures greater than 600 degrees can be sufficient to avoid cables falling when exposed to typical compartment fire. So that's their recommendation of fixing that can reach temperatures to 600 degrees with ease. So I'm rushing through this because you should know this really from our Amendment 3 update. But what's important is what we've learnt from this. The fire brigade, they learnt about the operating procedures. They had lots of extensive training about what's been going wrong in these cases, and the actual authority decided to try to attack this cable head on by employing this strap which goes over to the BA equipment, the breathing apparatus here between that. So it's just to avoid any cables going down there. You know, that's better than nothing. But what we have to ask is what we can do to help with this problem, and that is why this is here. Okay, wiring systems shall be supported such that they will not be liable to premature collapse in the event of a fire. So I go back to the beginning of this video and I ask you, when we're introduced with all these new regulations and we're told by everybody that yeah, here's all the new stuff, but don't worry, it's not retrospective. Is it acceptable to simply say that this regulation isn't retrospective? Because what we're then saying is it's acceptable to leave these risks within electrical installations for our firefighters to run into burning buildings and become trapped again. As much as we can plan on installing new systems to the requirements of the new regulations, we have to take some steps to safeguard firefighters by raising awareness of these risks that are present. And so I'm not saying you must now fail installations, because we can't do that, you know, it's not retrospective. What we need to do is recognise when there is cabling that is going to be liable to premature collapse in a fire condition, and decide what actions we can take as competent people. My advice is trying to assist anyone, your clients, your organisation, or whatever it is, who may have a responsibility for fire risk assessment. Those are the principal persons, because they have to safeguard the fire authorities as well. You know, anyone who tackles a fire, they'll have to make sure that they're safeguarded as well. So anyone who carries out fire risk assessments will, if they've not already been informed of this, they'll want to be made aware of where the cabling is and what action should be taken. Now this could be landlords, local authorities, housing associations. Again, it's a very, very long list of sites that haven't had any action taken to improve that. And if you think about it, it's not a lot to improve that. It is additional fixings to existing containment systems. It might just be that no one really, other than us electricians, because we have the regs, has been informed on this, really. And that's something that you need to kind of just take on board. Also have a think about other contractors. It is only in our BS 7671 standard. I have seen a couple of circulars and flyers, mostly pushed around by manufacturers, to be honest. But you may have people who install data, CCTV, door entry systems. They'll put in cabling in trunking or cabling in other containments, and they won't necessarily have a copy of BS 7671 on their hip to follow. And we need to obviously make sure everyone is aware. Whenever we go to a site, we've got to do our condition report, do our inspection report as we would. But if there is any cabling that hasn't been improved, I'm not saying we're going to fail the system, but what I'm saying is you have the space on your paperwork to advise the customer on improvements that are needed. And don't just say there's a regulation, but give them an explanation of the purpose. You can even give them a handout or something, but make sure that it's passed on to the right person, the fire risk management person, the duty holder, whoever that is. Because there are many systems where the cabling hasn't been tackled, it hasn't been fixed, it hasn't been improved, and what we're going to end up having is more firefighters perish, because whilst we're doing the right thing with our new systems, because these old systems aren't retrospective, we're not taking the right attitude to improving them. And that's why I wanted just to add this video here. If you're on site, you're doing a report, think about what you could do on paper to pass to your client, what information you could give them just so they can work with to try and tackle this and avoid this happening again. Cheers.